In this lesson, we're going to be doing some calculations involving sine, cosine, and tangent. Now, whenever you use sine, cosine, or tangent on your calculator, you have to make sure that you are in the mode appropriate for the types of questions you're doing. And it only comes up with sine, cosine, or tangent, so this does not affect anything else like square roots or anything else that you do with your calculator. In our case, for what we're doing today, we're going to be doing everything in degrees. So you need to make sure your calculator is in degree mode, not radians. So take a look and make sure that your calculator is in the right mode. You can check to make sure it is in the right mode. If you can do sine of 30 degrees and get an answer of 0.5 out. Make sure that you can do that calculation and get that as your answer. A couple tips I can give you here is that if you're on a graphing calculator, if you press the mode button, that'll let you choose whether you are in degrees or radians. And some calculators, usually not the graphing calculators, but some calculators will show like DEG or RAD, something like that on the top of your screen. Like if you're looking at the window, it'd probably be like written really small up here, that sort of thing. That could also be used to tell you whether you are currently in degrees or radians. If you are on one where it is displayed kind of like that, what you can look for is maybe a button that also might say DRG. That is also often used to be able to switch between degrees and radians as well. You just keep pressing it till it shows degrees. If not, well, then you might try Googling your particular calculator model as well as the question of how to switch between degrees and radians. But again, make sure you can do that, and then make sure that you can plug this into your calculator and get the right answer. For some of your calculators, you press sine and then press 30 and then press equals. Other calculators, you enter 30 and then just press sine. No equals needed. Make sure you know how to use yours. All right, now that we got our calculator working, we will solve. So in this particular question, we're told that the measure of angle C, and remember that's all that M means, is it means measure, and this symbol just means angle. So the measure of angle C is 27 degrees, and B equals 65. So this is telling us that the length of side B is 65 units. And we're going to be trying to find side A. When you do these types of problems, and you should be pretty adept at doing these by the time we're done here, one of the biggest things that I would suggest you do is that you make a quick little drawing on your own paper. Draw a right triangle, and then label these specific parts that we know. So if I were doing that on my own paper, this is what it might look like, where I don't care about all that extra stuff. All I care about is the 3 pieces of information that I'm working with. That is the 2 pieces that I was given and the one that I want to know. The beautiful thing about doing this is I now can just focus on what do I know and then what do I have. You'll notice here that I know the 27-degree angle. That means that that's the angle I'm going from. Because an angle is involved, I know I'm going to be using either sine, cosine, or tangent. And remember how we define each of those. You might remember SOHCAHTOA. Remember, sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. We're going to be using one of these 3 in order to solve this, and I know which of the 3 because I go from this angle, and then I name the other 2 sides that were involved. So the 65 side up here, that is the hypotenuse. The A side down here, that is the adjacent. And so you notice this problem involves the hypotenuse and the adjacent. I look over here for the fraction that includes the hypotenuse and the adjacent, and I find it right here, which means that I'm going to be using cosine to solve this problem. So the first thing I do now is I write cosine of the angle. The angle is always what goes inside of cosine. It's never a side length that goes into cosine or sine or into tangent. Now when we get to the inverses, we can put some side lengths into the inverses. But this is not an inverse, therefore you put the angle into it. All right, and so we do cosine of the angle, and then remember cosine equaled adjacent over hypotenuse. So I'm going to do the adjacent length on the top, which was A, and the hypotenuse length on the bottom, which was 65. There's my original equation. I now need to solve this equation. And there are two main methods that people use for solving this equation. The way that I naturally tend to look at it is I say, well, I'm dividing by something over here, so I'm going to multiply both sides by that. And so you could do that to both sides. One little side note on this. When I do that, I am not multiplying the 65 by 27. No, because the 27 is trapped inside of cosine. I would actually be multiplying it out front of the cosine, so I'd end up with like 65 times cosine 27. But I'm actually not going to do it exactly this way, because I said there's two different methods. Now that's the way I do it, just because it makes the most sense to me. But what I've found is that for most people in Algebra 2 at least, it actually often will make a little bit more sense if I instead write it like this. You'll notice that all I did was I wrote cosine of 27 as cosine 27 over 1. I'm turning it into a fraction. Why would I do that? Because now I have a proportion, that is a fraction equal to a fraction. And when you have a fraction equal to a fraction like this, you can cross multiply in order to solve it. And so in order to do that work, when I do the 1 times a, that just ends up giving me a. And if I do 65 times cosine of 27, again, that must be written as 65 times cosine of 27 like that. I do not, and I cannot multiply the 65 by 27. All right, so now I have it set up about how I'm going to calculate it. I know what a actually equals. I just don't know what that is as a number. So now it's calculation time. So break out your calculator, and then the very first thing you want to do is the cosine of 27 degrees. So do that first, and then once you have that number, then you're going to multiply that by 65. Let's check and see if you got that right. You should be getting an answer here of about 57.92. Now a question here, let's make sure that we're tracking, that we get what this answer really means for us. This 57.92, should I write a degree symbol right here for it? The answer is no, because little a here is a side length, not an angle. Angles are measured in degrees. Side lengths are measured in other units. Now, we were not told what those units were here. If you really wanted to be picky, you could actually write it like that, but that's as good as you can make it. But specifically, it would not be degrees. Now, one little reminder here as we go through this. It can be very tempting that all of a sudden, anytime I give you a triangle, that you're going to start by jumping into sine and cosine and tangent. But remember, the first thing that we need to have true about any of these is that it has to be a right triangle. So always be looking for that little box in the corner, or to be told that it's a right angle or a right triangle or a 90 degrees written in there, something like that. Because without that, we actually can't do these. Let's go ahead and go on to one more of these. Here, I've pre-labeled it for you. And so from this point, I want to see if you can solve it just from being given this drawing. So first, you will need to start by labeling your opposite, adjacent, and hypotenuse. Then use that information to decide whether you'll use sine, cosine, or tangent to be able to solve it. Because once you've decided between sine, cosine, and tangent, then you can set up your equation, and then you can solve the equation. So basically, these are the steps you're going to go through on any of these problems. And if it helps you, go ahead and write those steps down so you're going to remember it. But go ahead and try it with this problem. Pause the video and then play again after you've had a chance to try it. In this one, because we're going from the 55-degree angle, the 41 is the adjacent, and then B is the hypotenuse here. And so adjacent and hypotenuse tells us that we're going to go with cosine again for this one. So I do cosine of my angle, so cosine of 55 degrees. And remember, cosine equals the adjacent over the hypotenuse. So my adjacent side is going to go on the top, and my hypotenuse side goes on the bottom. Now you notice in this case, that means that B is on the bottom. If you want to use kind of my way of doing it, you'd multiply both sides by b at this point, and that's perfectly fine. But it's at this point that sometimes that messes with people's heads a little bit, and sometimes we find a little bit more comfort by going ahead and writing it as a proportion like this, and then going ahead and cross multiplying. But when you cross multiply in this case, you'll notice that our result isn't quite as helpful as it was the last time. Because the last time, we ended up with A equals and then how to calculate it. In this case, I still don't know what B equals. And sometimes people, when they hit this point, they start thinking, oh, did I make a mistake? You didn't make a mistake. No, it's fine. It just means you got to go through one more step to get B by itself. Because right now you have B times cosine of 55. Well, if you had 2x and you're trying to solve for x, you'd divide both sides by 2, right? If I have b times cosine of 55 and I want to get b by itself, I can divide both sides by cosine of 55. And so we go ahead and we do that to both sides. And again, remember that cosine of 55 degrees is one chunk. That is actually a number that we just haven't calculated yet. So you do not pull apart the cosine and the 55 degrees. The only time we try to pull the cosine apart from it is when it's cosine of x, and we're trying to get to x, is that creamy little center in the middle. In this case, I know what it is. It's 55, so I don't need to pull it apart. So we divide both sides by cosine of 55, which means that in order to get my answer of b, I'm going to have to do 41 divided by cosine of 55 degrees. This is another one where you need to learn how to use your particular calculator tool. Okay, so make sure that you know how to enter this in. Let's give you the answer. You should be getting an answer of about 71.48. Play with your calculator here. Check the correct order in which to press those buttons using what you know already until you can get that as your final answer. And then you're ready to move on here. All right, for our next question, you notice that this one is similar but a little bit different. The difference in this particular problem is that in this case, we are trying to find the measure of angle C. So in this case, we're actually going to try to figure out what the angle equals given two sides. But our first steps are still very similar. Step one would still be to make a drawing of the triangle with the pieces that we're dealing with, just these three pieces labeled on it. And so if I do that, now my vision is a little bit more focused on what I actually have to worry about here. Okay, step one of what we did before was to decide what we call the sides involved, opposite, adjacent, and hypotenuse. It would be the same for a step here. And so the 15 and the 13, these are relative to the angle that we're working with, so it's got to be relative to angle C. The 13, you'll notice, is the adjacent, and the 15 is the hypotenuse. And so that already tells us some direction. Now before, we then said, once I know that, then I can decide between sine, cosine, and tangent. Well, we still can do that. We can still say this one involves adjacent and hypotenuse, and therefore know that this one is going to be cosine. Nothing has changed in that regard. Okay, well, step three before was then to write an equation. We can write an equation here. It's just the only difference is that when I write it, it's cosine of C now, not cosine of the angle measure, because I don't know what the angle measure is. The angle measure is C, so it's cosine of angle C. But cosine still equals adjacent over hypotenuse, so I grab that adjacent and the hypotenuse, and I plug those in. There's my original equation. And now that I've written that original equation, it's a matter of actually solving it through from there. So remember the work that we were doing before where we were solving something where it'd be like cosine of the angle equals a number? Same thing. Yes, it's a fraction here, but that actually doesn't change anything. I want to be able to get the C here by itself. If I want to get it by itself, that means getting rid of the cosine. And to get rid of cosine, we do inverse cosine of both sides. So doing inverse of cosine on both sides cancels out this cosine on the left, and it leaves us with inverse cosine of the fraction on the right. Now we need to do that calculation. And again, the type of calculator you're using is going to change the order you put it in. Some of you are actually just going to be able to type it in exactly as you see it. You can do inverse cosine, and then you can just type in 13 divided by 15 and press equals, and you're done. Others of you, you'll start by doing 13 divided by 15, press equals, so you get the decimal showing on your screen, and then do inverse cosine, and it will show you the answer there. If you're doing it correctly, you should be getting an answer here of about 29.93, which, yes, is measured in degrees because inverse cosine tells us what the angle was, and angles are measured in degrees here. So make sure that you can do that calculation using your calculator and get that right answer out. Now, before we go on to the next one, just one little side note I want to tell you. In these three examples that we went through, I actually just chose to focus on cosine. So all three of them happen to use cosine. There's nothing special about the fact that they were all cosine. It was just showing that there were three different ways that even cosine could work out. You'll actually find the same variations with sine and with tangent. The only difference about knowing which one to use, sine, cosine, or tangent, is determined by which of the original side lengths we're working with here. We use cosine because it was adjacent and hypotenuse. If we threw the opposite in there instead of, say, the hypotenuse, then it'd be tangent. If I knew the hypotenuse, but I didn't know the adjacent, then we'd be dealing with sine. So it's always just a matter of looking to see what it is they're actually working with in that particular problem. That will tell you whether it's sine, cosine, or tangent. And here is our next right triangle practice problem. In this case, we are being asked to find the unknown side length. So we're looking to figure out what side C is. And in this case, what we know is those two sides are 6 and 8. And we also do know that it's a right triangle, which of course ends up often being necessary information here. All right, so in this particular case then, you might be tempted to then say, okay, well, first thing I need to do is figure out opposite, adjacent, hypotenuse. Okay, but are we going from angle A or angle B? Well, no, neither of those is involved, right? Well, then would you go from angle C? No, angle C is the right angle. Well, then how can we do it? Well, it turns out this one is actually one that you could have done a couple years ago. You don't even need trigonometry to be able to do this one. Sine, cosine, and tangent are unnecessary in this case. Way back when, you learned a little formula that comes up in right triangles. Remember the Pythagorean theorem? And so we can actually use the Pythagorean theorem to figure this one out. Where, remember, A and B are the legs of my right triangle. That is the two that border the right angle. And C is always the hypotenuse. Now, I'm going to go ahead and call it 6 squared plus 8 squared equals C squared. But if I had instead written it as 8 squared plus 6 squared, that would be perfectly fine. There's no magic or no rhyme or reason to why the 6 would come first or the 8 would come first. Those two are totally interchangeable. All right, now we actually just figure it out. So we do 6 squared, which is 36, and then we do the 8 squared, which is 64. Remember, we have to do the exponents before we do that addition. So now that I've squared them, I can go ahead and add them together. So I get 100 equals C squared. And then we can figure out what C is by taking the square root of both sides. And so we end up finding out that C equals 10. Now, if you're very astute and you've been following along with me all year, you might be remembering, wait. When we take the square root of both sides, we need to remember the plus or minus. Don't we need to say plus or minus in this case? Well, if all I gave you was just a straight equation and no context, yes. But because this is in the context of this right triangle, and we know that the side lengths of a triangle cannot be negative, that's why we can know that it's actually only 10 as the answer. Now, if you didn't remember that stuff about Pythagorean theorem, you might want to put this onto your notes so that you'll remember to come back to it later as you need it. All right, let's practice it with this one, please. And I would suggest that you actually try doing it yourself first, and then come back and watch the rest of the video. So in order to be able to do this one, notice there's no angles involved up here or here. All we know is that it's a right triangle. Well, that's enough for us to know Pythagorean theorem. And so, yes, we will use Pythagorean theorem here, But when I set it up, I need to pay special attention to where that x is going to go. Because you notice the x is one of the leg lengths. It's not the hypotenuse. And so when I set this up, I'm going to write it as 5 squared plus x squared equals 13 squared. Now, if you had written it on your own as x squared plus 5 squared equals 13 squared, that is perfectly fine. That is the same thing. Remember that the two legs are interchangeable when we put them in this particular formula. The part that matters and that is not interchangeable is the hypotenuse. That always has to be the one that's by itself. All right, so now that we have it set up, now we start doing the math on it, which in this case means squaring our numbers first. So we're going to have 25 now plus x squared equals 169. Well, I want to get the x squared by itself, so I'm going to subtract 25 from both sides. And so now I know that x squared equals 144. Now I can take the square root of both sides. And again, I don't have to worry about the plus or minus because I'm talking about the length of a side of a triangle. And the square root of 144 is 12. So that's our final answer. All right, last problem out of this lesson. This one is just given to you in words. So we know the hypotenuse of a right triangle is 30 inches long. If one leg is 18 inches long, how long is the other leg? And for many of you, you might feel totally comfortable going straight into your equation based on that information because we're talking hypotenuse and legs. If not, draw a picture. Pictures are very, very useful in this particular section. Now, you'll notice that I only have two numbers on here, the 30 and the 18. I need one other piece, either an angle or a side length. Well, what it is that we're trying to find here is the other leg. And so I'm going to go ahead and give that a name. I'm going to be uncreative here. I'm going to go ahead and just call that x. And then this one starts looking a lot like that last problem, doesn't it? And so we can go ahead and solve from here. I do 18 squared plus x squared equals 30 squared. Then the next thing I'm going to do is go ahead and square those two numbers. And then once I've squared those numbers, I can go ahead and subtract the 324 from both sides. And then to find out what x is, I take the square root of the 576, and that gives me 24. Now in this particular problem, we are actually told some units because we were told that these were both in inches. So I'm going to go ahead and include that in my answer here as well and say that my answer is 24 inches is the length of that other leg. Now in this lesson, we actually saw two main different ways of figuring out a missing part of a right triangle. Please make sure that you note when to use each one. If there is an angle involved, you need to use sine, cosine, or tangent. But if there's only sides, you're going to use Pythagorean theorem. However, in all of those cases, they all require that you have a right angle involved.